Welcome to a new test and teardown video. This time it's a Philips frequency counter called Universal Counter SBC 550. And thank you very much, my newest supporter, Torben Larsen, for sending this one to me. So this is going to be a lot of fun playing with this thing. I heard it is not working. So what kind of defects we got and what is working and what is not working, this is going to be a lot of fun. So for being a Philips, I'm a little bit, really? Because Philips normally makes really high class goody stuff. But what do you think that is? Look at that text and the switch. I mean, I'm not impressed. How can you do this? It should be in the line like, I mean, come on, Philips. This is not good enough. And the text here. Okay, so we got two different inputs, or A, B, C, and we got probably different frequency ranges. And this one is very tough to, we got a reset. Okay, this knob here needs to be moved, or maybe it's just oopsie doopsie. Maybe this one needs to be moved a little bit like that, right? So how about we just power it up and see if there's any smoke in this one first of all, right? That is going to be most fun. Yeah. SBC 550 and blah 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 Belgium. All right. So it's connected for 220, and this is written in silk screen like that. So what if you connect it for something else then? Duh. All right. I kind of like this input and output, by the way. So if you've got more instruments, it's just short cables like that, and that will save you a lot of cables and stuff, so you don't need to have all these like I got, right? This is a lot of crap. Well, this is real smart. I took the lid off because I hear this. Where is this? Can you hear this? Where is it? So there's the input module. We only got a few wires coming out of that module, and it's full of all sorts of goodies. And the power supply is also very simple. So this is the on-off switch, and then that is probably in series with the oh no, it's not. Look at that. Mains go into the transformer, and then it is on the low voltage side. Wires go to the on-off switch. So that means I should expect a tiny little power consumption. Yes. 1.1 watt of idle power consumption. That is the transformer running always. So that is something you need to be aware of. Well, it's only if you got 100 of them, it's going to be a big problem, right? But it's just fun. Ooh. Red LEDs. That is beautiful. I actually thought it was LCD when I saw the screen, but it's definitely red LEDs. That is nice and beautiful. So here is what we got. Frequency mode. Right. Reset. What we see here is just loose connections in the switch, right? So if we go to 1 second, there's no blinkety blink per second. And here is 1 megahertz. I tried all inputs because I kind of don't know what kind of inputs. Oh, look at that. That was actually a ha 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 haba haba. Finally. So channel input A is working. That is 1 megahertz of input. Fantastic. Let me try and change this to 2 megahertz and see if that, yeah, it is working. At least in input A, and the frequency here is like that. So what if we go, so that's probably another input, right? It could have been a smart idea to write this. So this is if the frequency is more than 10 megahertz, it's probably another input, right? So let me give it 20 megahertz. Haha, 20 megahertz. So when are we going for input C? How is this working? So this is the different. Ooh. Oh. So it should take 10 seconds for it to measure 20 megahertz with that many decimals. But why? That shouldn't take that long, should it? Well, I mean, so far it's working. Input B. So why don't I just give it like 200 megahertz? Oh, let's go back. That is 200. How about 400 megahertz? That seems to be working as well. Okay, let's 500 megajoules. Oops, that's not working. 450 mega. Okay, so 450. So it's not. So when is it we're supposed to use input C? No. Maybe it has something to do with the ratio, see, A versus C, right? So that will be. Aha, this is the idea. Oh, this is me who is absolutely stupid. Well, they could have made a little nice line from this switch, but it's maybe that obvious. Maybe it's just me who's absolutely dumb as a, I don't know. Of course it's like that, right? So that is more than 10 megahertz, but it goes to, let's crank it up slowly and see when it's crabbity. Okay, 460 megahertz is how this thing works. So there's a little bit of sensitivity issues, obviously. But I mean, it's not defect so far. And, playing around with this thing quite a while, and it is a little bit unstable when frequencies are over 400, so it is not capable of doing 500 or 550 definitely. So there is something with input B that is a little bit on the low sensitivity or low speed mode, and there's also a little bit problematic with this switch is full of noise. So when I move this between the different ranges, sometimes, okay, it's typical. Now yeah, you see, that is the problem. So this switch is definitely not reliable anymore. But I figured out if you do a little bit of tweaking around like that, and then just wait a little bit and see, then it works again. So as long as you know this switch is funny. So let me try the different modes here, the ratio A versus C. And we've got oscillator. I think it should be able to show the oscillator frequency, right? And count. Okay. Okay, so this is count. Yes, it is. Okay, so there's... Ah, that is the problem. It is this. Okay, here we go. So that is not going to be easy if you don't know where you are. All right. So count seems to be working. And then time. What kind of time? Aha, this is time per... Okay, hang on a second. I will change the input. Okay, so this is again count with this input. And now I got 100 hertz. So I don't understand what time is. How time is... What is that? How's that going to work? Don't tell me anything about how I need to set this up. Period. Okay, that is obviously because we're now in microseconds, right? So this is how many microseconds per input, and I am running in 100 hertz. So I mean, that kind of works as well. So all I have to do now is play around with ratio. Okay, so ratio A versus C. And here it is very obvious there is some funny stuff going on with this switch. Okay, so the ratio of 1 means that I'm running 10 kilohertz in that one. So A is 10 kilohertz and here's 1 kilohertz. But it can divide this one by 10 and make the ratio 100 to 1, 1000 to 1. Ha, that is so cool. But definitely the biggest problem is that switch. But I mean, okay, ratio also works. Super. How cool is that? So what is us? Ah, damn it! Now that works. Okay, has that something to do with my inputs? No. Of course, that is a test of its internal frequency, right? So that also works. Definitely it wasn't working before, but I think it has something to do with that switch. Okay. Okay, so all I have to do now is get time to show some time. What time? What kind of time? What time is it? What do you want me to do? What are you up to? Okay, time. Oh. Oh dear. So time has some... Aha! Here we go. That is time between the two inputs, A and C. Yabba dabba doo. Quite cool. You can measure time between two inputs. I'm running a 10 hertz signal and a 10 hertz signal on two signal generators here. And let me show you some fun thing. If I change one of them to 11 hertz, 12. Of course you get this. So this is a time sine wave because now they're sliding. Haha, that is really cool. So I mean, this unit really works. So now we are looking inside this unit, and it's using this classic frequency counter chip that's driving the 7 segments directly, and it's doing everything, all that. And that is the trimmer capacitor for the 10 megahertz reference oscillator. And what will be the 3 input sections? I think we should try and get inside that module here, right? Because that should be quite easy as far as I can see. I mean, mechanically this is done quite well. Look at that, all that grounding, shielding, and holding everything good together here, so that's pretty good. Oh, I took off the side panel so we could see a little bit better what is going on here. So in the B input, that's going all the way to 550 megahertz. We can see it here in the, we can see the input capacitors. It's amazing, it's handling 260 volts. And then there is a module, an amplifier divider module or something like that, right? And then we got some other ICs as well. And we can actually see the top of the module here. That black single inline module. And we can't really get all the way in here because this metal here is under here and it's just impossible to access. But what else did I do with this unit? Yes, I took out the main capacitor, and what do you know? This capacitor has absolutely no weight at all. So I just took another one, and that, yeah, this is full of good stuff, definitely. How cool is that? So I'm gonna put that one in. So at least I did something. So I think I will call it a day for this really nice frequency counter with quite a lot of really good and useful features. There's only this little thing here that is not working, and of course both of those switches are just very, very ready for replacement. So that is what we need to do with this unit. As you can see here, it is just, I mean, just look at that one, how unstable it is, right? It's supposed to show the 10 megahertz. Here we go. Really, really bad switches here. But anyway, thank you very much for watching. See you again tomorrow.